service conductors require a 4-wire feeder to maintain separation of the neutral and ground. National Electrical Code, or NEC, Section 250.24 FIV mandates a grounding electrode system at each service. NEC Section 250.26 requires the system to connect to the neutral at the service point. The implication is that the neutral and ground must be separate. In this scenario, the conductors originating from the outside disconnect and supplying the new structure function as the service conductors for that building. Hence, a 4-wire feeder is essential to ensure distinct neutral and ground. A 4-wire feeder system includes 2 hot wires, a neutral wire, and a ground wire. The neutral wire carries the return current from the load back to the source. The ground wire provides a low impedance path for fault current to return to the source, tripping the overcurrent protective device and clearing the fault. Separating the neutral and ground wires is crucial for safety and proper system operation. If the neutral and ground are bonded together at the subpanel, a portion of the neutral current will flow through the ground wire, creating a potential difference between the ground wire and earth. This potential difference can cause stray voltages, which can interfere with sensitive electronic equipment and pose a shock hazard. Furthermore, bonding the neutral and ground at the subpanel violates NEC regulations. The NEC specifically requires that the neutral and ground be kept separate at subpanels and only bonded at the main service entrance. This separation ensures that fault current flows through the designated ground path, minimizing the risk of electric shock and equipment damage. The service conductors must be sized appropriately for the anticipated load. The NEC provides guidelines for calculating the service load and selecting the appropriate conductor size based on ampacity. Factors to consider include the type of building, the types of loads served, and the voltage of the system. Overcurrent protection must also be provided for the service conductors. Overcurrent protection devices, such as circuit breakers or fuses, protect the conductors from overload and short circuits. The overcurrent protection device must be sized to protect the conductors according to their ampacity. The grounding electrode system must be properly installed and connected to the neutral at the service entrance. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system provides a low impedance path to ground, which helps to stabilize the system voltage and protect against electrical shock. The installation must comply with all applicable codes and regulations. Electrical work should only be performed by qualified individuals. Understanding NEC requirements for grounding and bonding is crucial for ensuring safe and reliable electrical systems. Separating the neutral and ground at subpoles, using properly sized conductors and overcurrent protection, and installing a grounding electrode system are all essential steps in achieving this goal. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidance. Remember to verify the ampacity of the conductors and the rating of the overcurrent protection device to ensure they are adequate for the intended load. Pay close attention to the grounding electrode system requirements, ensuring proper installation and connection to the neutral. Furthermore, any future telecommunication installations from the first building to the second should adhere to the relevant sections of the NEC regarding bonding and grounding of communication systems. This ensures that the telecommunications system is properly integrated with the electrical system and that potential hazards are mitigated. Telecommunication cables entering the second building should have their shields bonded to the building's grounding electrode system. This bonding helps to prevent voltage differences between the telecommunication system and the electrical system, reducing the risk of electrical interference and equipment damage. The NEC provides specific requirements for bonding and grounding telecommunication systems, and these requirements should be carefully followed during the installation process. Specifically, Article 800 covers communication circuits, and Article 820 covers coaxial cable. These articles provide detailed guidance on bonding, grounding, and separation requirements for telecommunication systems. Ensure that all telecommunication equipment is properly grounded and bonded in accordance with these requirements. Also, consider the potential for electromagnetic interference, or EMI, from other sources. EMI can disrupt telecommunication signals and degrade performance. To minimize EMI, use shielded cables and properly ground all equipment. Keep telecommunication cables away from sources of EMI such as power cables and electrical equipment. In addition to the NEC requirements, local codes and regulations may also apply to telecommunication installations. Check with the local authorities to determine the applicable codes and regulations. It's also important to maintain proper documentation of the electrical and telecommunication systems. This documentation should include drawings, specifications, and test results. This documentation can be helpful for troubleshooting problems and making future modifications to the systems. Regularly inspect the electrical and telecommunication systems to identify any potential problems. Look for signs of damage, such as frayed wires, loose connections, or corroded components. Address any problems promptly to prevent further damage and ensure the safety of the systems. When performing any electrical or telecommunication work, always follow safe work practices. Wear appropriate personal protective equipment, such as gloves and eye protection. Energize circuits before working on them whenever possible. Use insulated tools and equipment. And never work alone. By following these guidelines, the new service will be safe and reliable. Remember that this is a general overview and the specific requirements for an installation can vary depending on the location and the type of building. Always consult with a qualified electrical contractor and refer to the latest edition of the NEC for specific guidance. Remember, electrical codes and regulations are subject to change. Staying updated with the latest requirements is crucial for ensuring compliance and safety. Subscribe to relevant industry publications and attend continuing education courses to keep abreast of the latest changes in the electrical code. Engaging in professional development activities ensures that your knowledge and skills remain current, allowing you to provide safe and compliant electrical installations. Also, consider the impact of energy efficiency on the electrical system design. Incorporate energy-efficient lighting, appliances, and equipment to reduce energy consumption and lower operating costs. Energy-efficient designs not only benefit the environment but also reduce the load in the electrical system, potentially allowing for smaller conductor sizes and reduced overcurrent protection requirements. Furthermore, consider the potential for future expansion of the electrical system. Design the system with enough capacity to accommodate future loads. This may involve installing larger conductors and overcurrent protection devices than are currently required. Planning for future expansion can save time and money in the long run. The selection of electrical equipment should be based on quality and reliability. Choose reputable manufacturers and suppliers that offer products that meet or exceed industry standards. Using high-quality equipment can reduce the risk of failures and extend the lifespan of the electrical system. Proper labeling of electrical panels and circuits is essential for safety and maintenance. Clearly label all circuit breakers and disconnects to identify the circuits they serve. This labeling helps to prevent accidental energization or de-energization of circuits during maintenance or troubleshooting. The new structure may also need emergency lighting. Emergency lighting provides illumination during power outages, ensuring the safety of occupants. Emergency lighting systems must comply with NEC requirements and local codes. Consider installing a backup generator or uninterruptible power supply, or UPS, to provide power to essential loads during power outages. Backup power systems can ensure the continued operation of critical equipment and systems, such as life safety equipment and data centers. The location of the disconnect is also important. It should be readily accessible and located in a safe location. The disconnect should be clearly labeled to indicate that it is the main disconnect for the building. Surge protection devices, or SPDs, can protect sensitive electronic equipment from voltage surges. SPD should be installed at the service entrance and at subpanels to provide comprehensive surge protection. Voltage surges can damage electronic equipment and cause data loss. Therefore, it is essential to install SPD to protect against these events. Harmonic distortion can be a problem in electrical systems with nonlinear loads, such as electronic equipment and variable frequency drives, or VFDs. Harmonic distortion can cause overheating of equipment, increased energy consumption, and interference with other electronic equipment. To mitigate harmonic distortion, consider using harmonic filters or reactors. Regularly inspect electrical equipment for signs of overheating, corrosion, or damage. Overheating can indicate overloaded circuits or loose connections. Corrosion can weaken conductors and connections. Damaged equipment should be repaired or replaced promptly. Implement a preventative maintenance program to ensure the continued reliability of the electrical system. Preventative maintenance activities may include tightening connections, cleaning equipment, and testing overcurrent protection devices. Proper ventilation of electrical equipment rooms is essential to prevent overheating. Electrical equipment generates heat, and if the equipment room is not properly ventilated, the temperature can rise to dangerous levels. Ensure that the equipment room has adequate ventilation to dissipate heat. Conduct regular infrared scans of electrical panels and equipment to identify hotspots. Hotspots can indicate loose connections, overloaded circuits, or other problems. Infrared scans can help to identify these problems before they cause a failure. Regularly test ground fault circuit interrupters, or GFCIs, to ensure they are functioning properly. GFCIs protect against electrical shock by detecting ground faults. GFCIs should be tested monthly to ensure they are working correctly. Document all electrical work performed on the system. This documentation should include drawings, specifications, and test results. This documentation can be helpful for troubleshooting problems and making future modifications to the system. When making any modifications to the electrical system, always obtain the necessary permits and approvals from the local authorities. The electrical work must comply with all applicable codes and regulations. Failure to obtain permits and approvals can result in fines and penalties. Always use qualified electricians to perform electrical work. Qualified electricians have the training and experience necessary to perform electrical work safely and correctly. Using unqualified individuals to perform electrical work can be dangerous and can result in code violations. Educate building occupants about electrical safety. Teach them how to identify potential electrical hazards and how to respond in an electrical emergency. Electrical safety education can help to prevent accidents and injuries. Remember, electrical safety is everyone's responsibility. By following these guidelines, you can help to ensure the safety and reliability of the electrical system. The electrical system should be designed and installed in accordance with all applicable codes and regulations. Always consult with a qualified electrical contractor for specific guidance. By following these guidelines, the new service will be safe and reliable. Remember that this is a general overview and the specific requirements for an installation can vary depending on the location and the type of building. Always consult with a qualified electrical contractor and refer to the latest edition of the NEC for specific guidance. And always err on the side of caution when dealing with electricity.